Good morning to all. This video lecture covers Cayley-Hamilton Theorem and its uses. The definition of square matrix. A matrix having n rows and n columns is called a square matrix of order n. For example, A is a 2 cross 2 matrix and B is a 3 cross 3 matrix. Definition. Characteristic equation. The equation determinant A minus lambda I equal to 0 is said to be the characteristic equation of the matrix A. Here A is the square matrix and lambda is the eigenvalue. I is identity matrix. Statement of Cayley-Hamilton Theorem. Every square matrix satisfies its own characteristic equation. Uses of Cayley-Hamilton Theorem. To calculate the positive integral powers of A and the inverse of a non-singular matrix A. Example 1. If A is equal to 1, 0, 0, 5, verify Cayley-Hamilton theorem and write A square in terms of A and I using Cayley-Hamilton theorem. Solution. First we write the statement of Cayley-Hamilton theorem. Every square matrix satisfies its own characteristic equation. So first we find the characteristic equation of the matrix. Since the matrix is 2 cross 2, we find determinant of 1 minus lambda 0, 0, 5 minus lambda equal to 0. This is the characteristic equation of the given matrix E. On simplification we get 1 minus lambda into 5 minus lambda equal to 0. Then we multiply these two terms. We have 5 minus lambda minus 5 lambda plus lambda square equal to 0. On simplification, it becomes lambda square minus 6 lambda plus 5 equal to 0. We have to prove A square minus 6A plus 5I equal to 0 matrix. Therefore, we find A square. A square is equal to A multiplication A, which is equal to 1, 0, 0, 25. Therefore, A square minus 6A plus 5I equal to 1, 0, 0, 25 minus 6 into 1, 0, 0, 5 plus 5, 0, 0, 5. On simplification, we get 0, 0, 0, 0, 0 matrix. What we have proved, A square minus 6A plus 5I equal to 0 matrix. Hence, we have verified Cayley-Hamilton theorem. Next we write A square minus 6A plus 5I equal to 0 matrix. To express A square in terms of A and I, we write A square minus 6A plus 5I equal to 0 matrix. This implies we can write A square equal to 6A minus 5I. We have expressed A square in terms of A and I. Next. Example, using Cayley-Hamilton theorem, find A inverse when A is equal to 1, 0, 3, 2, 1 minus 1, 1 minus 1, 1. In this example, we are going to find A inverse by using Cayley-Hamilton theorem. First, we find the characteristic equation of the matrix A, lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. Here, S1 is the sum of the main diagonal elements. In the given example, the main diagonal elements are 1, 1, 1. Therefore, S1 is equal to 3. And S2 is sum of the minus of the main diagonal elements, which is equal to 1, minus 1, minus 1, 1, plus 1, 3, 1, 1, plus 1, 0, 2, 1, which is equal to minus 1. So, we have obtained S2, which is equal to minus 1. S3 is the determinant of the matrix. S3 equal to determinant of A. Determinant of 1, 0, 3, 2, 1 minus 1, 1 minus 1, 1, which is equal to minus 9. After finding S1, S2 and S3, we write the characteristic equation of the matrix A, which is equal to lambda power 3 minus 3 lambda square minus lambda plus 9 equal to 0. Here we apply Cayley-Hamilton theorem. So, we can write A power 3 minus 3A square minus 9A plus minus A plus 9I equal to 0 matrix. Multiplying by A inverse, we get A square minus 3E minus I plus 9 A inverse equal to 0 matrix. We need A inverse term, so we need A inverse. So 9 A inverse equal to minus of A square minus 3E minus I. Therefore, A inverse equal to minus of A square minus 3E minus I by 9. To find A inverse, we need A square and minus 3A. A square is nothing but A multiplication A. Just matrix multiplication. So, A square is equal to 4 minus 3, 6, 3, 2, 4, 0 minus 2, 5. Minus 3A. Just multiply A by minus 3. Minus 3A is equal to minus 3, 0, minus 9, minus 6, minus 3, 3, minus 3, 3, minus 3. Therefore, 1 implies minus 1 by 9 into 4 minus 3, 6, 3, 2, 4, 0, minus 2, 5. Plus minus 3, 0, minus 9, minus 6, minus 3, 3, minus 3, 3, minus 3, minus the identity matrix. On simplifying, we get 1 by 9 into 0, 3, 3, 3, 2, minus 7, 3, minus 1, minus 1. This is the inverse of the given matrix A. In this video, we have seen the statement of Cayley-Hamilton theorem and its uses. Thank you.